Okay, so in this lesson we are going to talk about the reactions of polyketides. We are going to talk about two special molecules. One is this one, and the second one is this one, orsellinic acid and fluoroacetophenol. So we are going to talk about the mechanisms of these two molecules. Okay, we are going to start with the polyketide. So if you are having a question about like how the polyketides are formed, then you have to watch our previous video which we have talked about the synthesis of polyketides. I hope you remember those things. So mainly what you need to understand is to form a polyketide we have talked about the acetate pathway. This is the biological mechanism which synthesizes the polyketides, and you need to know two special molecules or two special structures which contributes to form this particular polyketide. One is the acetyl coenzyme A and another one is the malonyl coenzyme A. If you have not remember these things, or if you are not familiar with these things, I highly recommend you to go back to our previous video and watch it before you come into this particular video. So let's start. So the mechanism, okay, we are going to use this particular polyketide for mechanism for both our mechanisms to obtain one particular structure. We are going to move with Aldol reaction. I hope you are familiar with Aldol reactions. Let's move on. So first of all, what happens is you can see these are carbonyl groups, and these places, look at this, these places, you know, there are two hydrogens for these places. This hydrogen contains higher acidity because of these carbonyl groups. So we can use a biological base and remove one of this hydrogen to obtain this kind of electron pair. Now this acts as a nucleophile. Now I have drawn the same structure, a little bit ring-like. Okay, so let me number these carbon atoms so you can easily identify which carbon occurs at which position. So let me take this one as 1, this one 2, 3, 4, 5, 6, 7 and 8. Here 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so this is the same structure. Okay, same structure. I have just formed a ring from the same structure. Now what happens is basic aldol condensation. You can see this is a nucleophile. This will go and attack to this carbonyl carbon. Due to this attack, this double bond will be broken. Okay, so this double bond go and form a oxygen negative charge, or this will go and straightly attack to a proton. So I have drawn the structure after this bond attacked the proton. Now we have hydroxyl group. Okay, now we have the hydroxyl group. This is basically the aldol reaction. And then in the next step, what happens is, you know, there is hydrogen on this place. Okay, we can use a biological base which take this proton and break this bond to form pi bond between this carbon and this carbon. Due to this breakage, this hydroxyl group will be removed. So I have drawn that particular structure. So now we have removed a water molecule from the structure to form a double bond, basic dehydration step. So here you have the dehydration. You have the dehydration. This is the dehydration step. Now we have formed this particular structure. Now what happens? Enolization. So I hope you are familiar with enolization. That basically what happens is we are going to convert this carbonyl group into hydroxyl group with forming a double bond to adjacent carbon. So here I have drawn the final structure. We have hydroxyl group which is converted from the carbonyl components, and we have the aromatic ring in the middle. So this is the orsellinic acid, which is our first molecule we are expected to synthesize. I hope you got that particular idea. And in the next part, let me take the yellow color. Okay, now in our second mechanism we need to go with the Claisen reaction. So these two reactions, Claisen reaction and Aldol reaction, both are similar, but there is only one slight change. I will mention it through our mechanism. Now in the first step, what happens is that basically the same thing happen here, but on here our biological base, or our base in our biological system, attacks the hydrogen on this particular place. So if I number this ring, 1 2 3 4 5 6 7 and 8. Okay, now our nucleophile or our electron lone pair occurred at this particular place on 6th carbon. In here we have the 2nd carbon. Okay, now same thing happened with this ring formation. This will go and attack to this particular carbon. Okay, so what happens when this attack occurred? This particular double bond will be broken into the oxygen. So here we have the structure. Now this is the Claisen mechanism. In Claisen mechanism, what happens is this this lone pair will come back into the carbon and oxygen to form the double bond again. Now you know, to form this particular double bond, this carbon is going to be unstable. So the carbon has only one option left, which is has to break one of these 4 bonds. So these are particularly strong bonds. Only option is to remove this part. So with that we have this structure. You can see now that in sulfur containing part is being removed, and we have obtained the carbonyl group in this position back. I hope you got up to now. Then what happens? Again, just like here, we have the enolization. Here we have the enolization to obtain the aromatic ring on the center, and we have hydroxyl groups. So this is our second molecule which we are going to discuss. So these are pretty easy mechanism, not that much complicated, but there are some few important details which you need to focus on. First one is, if your question is like this, the structure is given to you and you are asked what is the pathway, what is the biosynthesis pathway to obtain this particular structure. Now for this level of examinations, you won't be able to like get the same structures as in your note, so you need to think about little how to identify the pathway. So this is basically the acetate pathway, which I have told you in the in our beginning of the video. Acetate pathway, how to identify it? The main way to identify it is this hydroxyl group. You can see these hydroxyl groups are not adjacent to each other. There's a gap between the hydroxyl group here. There's a gap between the hydroxyl group. If your hydroxyl groups are like this, then this is not acetate pathway, because in acetate pathway your polyketides are going to form like this. There's always a gap between the carbonyl groups. If your polyketide is going to synthesize in the acetate pathway, so there are always a gap between your carbonyl groups. So you cannot obtain a structure like this with acetate pathway. So best way to identify the acetate pathway is to look at the hydroxyl groups or carbonyl groups. If they have a gap in between, or the hydroxyl or carbonyl groups are not in adjacent positions, then definitely it's going to be acetate pathway. So I hope you got the idea about it. So, and other most important thing is the reagents, or the main molecules which we are going to form, which we are going to use to form these particular molecules, based up acetyl coenzyme A and malonyl coenzyme A. These are very important, so memorize these things. These things are the very important things on this particular biosynthesis pathway. So I hope you have no problem. So don't forget to subscribe, and we have talked about the polyketides, like synthesis of the polyketides, in our previous videos. Check it out. We have talked about many important things such as the acetate pathway and how to identify the acetate pathways, how these can operate in our biological systems. Thank you.